We'll be going over chain rule and calculus. So the chain rule states that if f and g are both differentiable and f of x is a composite function defined by f of x equals f of g of x, then f is differentiable and f prime is given by the product. As we see here, right, this is the f of x function, and it's given by the product of f of g of x. So knowing the format of chain rule, let's put this into practice. In this function, we can see that this inner is being raised to the power by 5. So therefore, this is being inputted into this. So we know that our outer function, right? We can label this as f of x is equal to x to the power of 5. And we know that the derivative of this by applying power rule is just going to be 5x raised to the power of 4. And then we can see that our inner function, the function we input into here, is simply what's inside here. So we have x squared plus 7. And then we know that the derivative is just going to be 2x, right? Because we apply power rule here, and we know that the derivative of any coefficient at any time is going to be 0. So now that we have this, right, we remember that the chain rule basically states that we take f of f prime of g of x times g prime. So we have our f prime, which we have 5, and we apply our inner function, what was inside, right? This is what's inside. So we have 2x plus 7. All raised to the 4th power, right? We're basically inputting this into here, right? Times, so we multiply this whole thing by g prime, what our derivative of what was previously, or what is here, not previously, right? Here, which is just 2x. This is equal to f prime of x. In this example, we see sine of x squared. Now in this example, we see sine of x squared. It's important to note that the square is inside and not outside. We'll take a look at another example when the square is on the outside. But for now, we see that it's inside. So here, we know that our outside function, right? Our outside function, we'll label that as f of x is sine of x, right? And we know that the derivative of sine of x is cosine of x. And then we know the function we're inputting into this x, right? What we're inputting is just going to be x squared. And we know that the derivative applying power rule of g of x is just going to be 2x. And now that we have everything here, we can apply chain rule, or we can write chain rule. So we have our outside function, our outside derivative function, is cosine of what was inside of x squared, right? What we saw here previously, all multiplied by our derivative of the inside, which is just 2x. And that is equal to f prime of x. In this example, now we see that sine to the power of 2 of x. So it is no longer within x, but it's on the outside, which you can also rewrite this as sine of x raised to the power of 2. Let me write that properly. There we go. Okay, so now what is our outer function? So our outer function is no longer sine of x, but rather it is x squared. And then we know that the derivative of f of x is just going to be 2x. And what we're inputting into here, right? What we input into x is just sine of x. So we see g of x equals sine of x. And that the derivative of sine of x, right, is just going to be cosine of x. Let me write that a bit better. Cosine of x. Oh, okay, applying chain rule. So now that we have our derivative here of the outside function, we have 2, and then we take what was the original input, right? Sine of x times our derivative or inside, which is just cosine of x equals f prime of x. In this problem, we see a trigonometric function where we see cosecant of x over 3. And here we know that our outside is going to be cosecant. And we can set that equal to f of x, just cosecant x. And we know that the derivative of cosecant is going to be negative. Oh, it's going to be cosecant. Oops, it's going to be cosecant x times. Let me make some room. Times cotangent of x. And we see what we're plugging into f of x. What we're plugging in here is going to be x over 3. And we know that the derivative of x by is just a coefficient and no exponent is simply just going to be 1 over 3. All right, applying chain rule now that we have everything set equal to each other. So we know that our outside function was, and we find the derivative of that, which is negative cosecant x times cotangent of x, right? So we know that h prime of x is going to be equal to negative cosecant, and what we see in the x, right, what we previously plugged in into the outside function, we're going to plug into this function, our derivative of the outside function. So over 3 times cotangent of x over 3. And now this is all going to be multiplied by the derivative of the inside function, which we found to be 1 over 3. Function, we see that we have x squared plus 7 all to the power of 2 over 3. So what is our outside function? What are we plugging into, right? What we're plugging into is x squared plus 7. That's going to be our inside function. And we're plugging that into x of to the power of 2 over 3. So we know that f, our outside function, is going to be x to the power of 2 over 3. And applying the power rule, we know that f prime of x is going to be 2 over 3 x minus 1 over 3. Now, we're going to leave it as a negative exponent. However, that's not correct. But later on, when we apply chain rule, we'll move this down into the denominator to make this mathematically correct. But for now, we're going to leave it like this. Now, g of x is our inside, what we plugged in here. So we have x squared plus 7, right? And we find the derivative of this. So g prime of x is just going to be 2x, right? Because the derivative of a constant is always 0, and the derivative of this, applying power rule, is just going to be 2x. So we have 2 over 3, and then we're going to move this down, right? And then when we move it down, we have 2 over 3 times x to the 1/3. but we can rewrite this as a cube root. So cube root of x, right? But we're going to replace it with what was inside. So what was inside was x squared plus 7. All multiplied by the derivative of the inside, which is just 2x, equals t prime of x. That is our derivative. Okay, in this problem, we see two things, right? So we have multiplication, and then we have a radical. So from just noting these two things, we know we're going to have to apply power rule, and we're going to have to apply chain rule. So let's rewrite this in the format that we can apply chain rule. So this is 2x times x squared plus 3 to the power of 1/2. Right? So knowing this, we can find the derivative of this, right, by applying chain rule. So first off, we're not going to apply chain rule just yet. We're going to apply power rule. So power rule is going to tell us to find the derivative of this and leave this alone, and then multiply them. That's the first part for power rule. So we're going to find the derivative of 2x. So the derivative of 2x is just 2 times this, the second part, but we're going to leave it as it is. X squared plus 3, right? And now that we have that, we're going to add it. Because we found the derivative of this, now we're going to leave this alone. And then we're going to find the derivative of this. But before we can find a derivative of that, we're going to have to separate into parts and find the inside and outer function. So we know that our outer function for here is going to be x to the power of 1/2. And when we apply a power rule, we're going to get f prime of x equals 1 over 2 root x. And we know that what we're plugging in here is 2x, x to the power of 2 plus 3. So we know that our g of x, not prime, just g of x is equal to 2x plus 3. And we know that the derivative of this is just going to be 2x. So knowing this, we can find the derivative of this part. And it's going to be, okay, so we see the derivative of f of x, our outer function, is going to be 1 over 2 root, and then what was inside, x squared plus 3 all times the derivative of our inside function, so 2x. And that is how you find the derivative of z of x. So the main takeaway that you should take from chain rule is that it helps us find the derivative of composite functions. So whenever you have something being plugged into something, you will know that you have to use chain rule. Chain rule is such a fundamental skill to know for calculus, and knowing when to use it and how to use it will help you exceed in calculus. As always, thank you for watching. Please make sure to comment if you have any questions.